Welcome back, YouTube. Today we're going to be talking about the exhaust design from the different three American automobile manufacturers. So whether it be Chevrolet, Ford, or Chrysler, we're going to talk about the exhaust side of the cylinder head for today's debate. Now, fair warning, I'm going to try to create some drama here, some controversy, because I want to hear everybody's feedback and maybe some proof from all these individual cylinder head porters with flow benches. If you have access to a flow bench and you have either a Chrysler or AMC cylinder head, I would like you to try two different exhaust pieces to identify the flow of the cylinder head between a tubular primary header compared to a cast iron manifold. Okay, so what led into this discussion is that the Chrysler LA cylinder head from the small blocks, we all realize that the exhaust side has a very large dip within the combustion chamber itself. So hopefully you guys can see this. Let's talk specifically about the short side. So let's say the top one is a General Motors small block Chevy camel hump. Okay, it doesn't really matter what it is as long as it has the radius of the exhaust, short turn radius, matched to the exterior or roof of the port. Now, any performance enthusiast realize that exhaust gases, they move in mass and at speed when there's less turbulence introduced to the flow. So mating a tubular exhaust system on a Chevrolet head, you're going to see some noticeable power gains. Now, we can argue about horsepower and torque. That's not the topic of this video. But now, if you were to look at the former cast iron manifolds offered by Chevrolet, your ram horn style exhaust manifolds, which way did they cause the exhaust gases to go before actually going to the exit point of the manifold? Especially when it is considering the outboard ports. The exhaust gases and the ram horns actually turn and go up first, then they come together as the collector in the middle of the block to actually exit. Now, in that configuration, it's without a doubt the highest performance cast iron manifold for the small block Chevy from factory design. Obviously, there's been different designs that have come out of the aftermarket to capitalize on that, so on and so forth. We're going to talk about factory cast iron manifolds. Now, if you look at the Chrysler 340 cast iron manifolds, you realize, especially because of the steering components, the manifolds are actually specific to the side of the engine, especially within your cramped engine compartments offered by Chrysler. You'll notice that the driver's side also goes up. They are not necessarily exiting the exhaust port straight out and then traveling down to underneath the chassis of the car. The driver's side one goes up, while the passenger side one mimics the Chevrolet design, where it actually dumps out and turns down before going into the log and then transferring to the rear of the exhaust manifold to the exit point. So between the three different designs, it's something that if you're a head flow individual, you're going to have multiple different specimens to test, both between the Chevrolet cast iron to the Chrysler left and right bank type manifold, and then take your choice of any aftermarket tubular header and flow your exhaust side to see the difference of what there is between the designs. Now, Chrysler, especially the earlier LA cylinder heads, not the Magnums, they're given a bad rap, especially the center two ports of the cylinder head, because of that large deviation, missing material within the ports. Now, remember, folks, flow is interrupted by tumble. So anytime the airflow is able to override itself or turn, it will cause back pressure. Now, if you were to couple a tubular exhaust system on a Chrysler LA cylinder head, the outboard ports are going to flow more than the center two. Why is that? Because the front or the outside cylinders are acting just like the Chevrolet port, where it resembles the exact same shape as the exhaust port through the tubes itself of the header. But when Chrysler was first designing their cast iron manifolds and cylinder head port configuration, they weren't using headers. They weren't using the 340 specific side of the engine type manifolds. They were using manifolds that needed to be very tight within the package. So now, knowing that information, why did Chrysler create the center ports different than the outboard ports? And can any of you cylinder head flow specialists out there, can you prove my theories? Now with the Chrysler, I'm going to enlarge it so you guys can see it a little bit more. Okay, let's say that it's an exaggerated drawing of the Chrysler exhaust port. Now this is a side sectional view. We're going to get to the side-to-side sectional view here in just a moment. Now when exhaust gases are escaping, we all know that air likes circumferences. They don't like straight walls or very sharp corners. And exhaust gases, exhaust flow does not like turbulence. So if you were to couple a tubular exhaust system on a Chrysler LA cylinder head, is there tumbling occurring within the cylinder head? Especially in this deep pocket right here. As the air is escaping the exhaust port, it is going around a radius, and it's a very tight radius. Excuse me. To the point where it causes tumble. Okay? Now that tumble is not being necessarily transitioned directly into the header style tubular exhaust system. What it is allowing the exhaust gases to do is to shift to where the outside, the roof portion of the airflow, to accelerate because of the resistance at the bottom of the port. The air on top has to do more of it, but it is receiving some restriction. Now, knowing that, why did Chrysler make the center two ports different than the outside ports? Again, we have to go back to the factory engineering. How were the cylinder heads or the manifolds attached to the cylinder heads themselves? What did they share in common? Starting from the side sectional view, inside of the cast iron manifolds themselves, they were a round log. So what were they attempting to achieve by attaching a log cast iron manifold to the design of the cylinder heads themselves, and what was different from the outside ports to the center? Now remember, the earlier original editions of the LA cylinder head had a center dump out. And with the traditional log style, so it was even across the ports themselves. It wasn't oriented below or above the ports as in the driver's side 340 cast iron manifold. And it didn't mate directly to the point where the exhaust gases are moving from the interior of the port through a tube. It was being exposed to an open area of the circular interior of the cast manifolds. Now on the out exterior ports, the airflow had to do more than just travel in one direction from inside the chamber to the exhaust. It had to be timed, so the exhaust impulses were timed to where when the number one cylinder went off, by the time the exhaust gases were reaching the exterior point, it was creating a negative pressure on the next within the firing order. And as you go through all 8 cylinders, or the 4 cylinders shared on that side of the cylinder head, the timing, once again, was engineered to create a negative pressure on the consecutive firing order within the engine. And the timing of the exhaust gases at where within the exhaust manifold was occurring at that RPM. Now, you cylinder head port flow characteristic guys out there, whatever, you always share intake flow and exhaust flow numbers, and you'll add in sometimes that if you add a pipe. Now, your pipe is simulating a tubular exhaust system, a header. I challenge you, okay, this is where I challenge you, on your entire cylinder head to block off your exterior ports, flow one of these center ones, but then add something large like an original log manifold. You will actually see that the center 2 ports on the Chrysler LA engine flow more than the exterior ports do. You heard that correct. The center ports, when attached with a cast iron design center outlet manifold, will flow more than the exterior ports do. Now, the later Magnum engines, they filled in that surface area. And you'll notice the difference between the exhaust manifolds on the engines equipped from approximately 1989 and later. They had a rear exit point within the manifolds. So the engineering of the LA cylinder head was prior to the engineering of the exhaust manifold. As an entire package, the very first LA designs had a center dump out, and exhaust manifolds were designed to work in that configuration. So if you're adding horsepower to an engine and you're automatically, jumping up to a header tubular type exhaust system, you're going to have an imbalance within the flow characteristics of the exhaust, especially with the Chrysler or AMC type cylinder heads, because once again, AMC cylinder heads are very similar to the Chrysler LA. They also have that very deep pocket on the short turn radius. Now that's the side sectional view. Now, if we're looking directly at the ports, you'll notice that the sectional view from the exterior looking into the port, the center 2 ports on a Chrysler LA engine have a droop tier like this, same as the AMC cylinder heads. Why is there a bias to have a directional casting within the center 2 ports of either one of those engine families? Specifically those dropped areas. It creates turbulence, right? Because the airflow at the top of the port is going to have to curve around the higher pressure area being created within that tumble. Now, once you realize that the ports are different from the outside to the center ports, why did both Chrysler and AMC design their cylinder heads with that large teardrop to reduce the flow of the center 2 ports? Again, it goes back to the actual factory cast iron manifolds that were utilized in both manufacturers. They both had center dump out exit points for their exhaust manifolds. So when you're trying to achieve equal balance between the flow of all the ports, we all realize that the intake, the more even you can have within the spread of flow of your intake, say a spider type single plane intake, gives you a little bit more of a balanced horsepower creation between all 8 cylinders. Okay, if you're flowing 250 CFM on one port and the next one only flows 190, you're only going to flow the maximum that the intake can allow through the cylinder head. So you're going to have an imbalance. So you're going to have more airflow and fuel being delivered to one cylinder, and there's going to be less air and fuel being delivered to the second cylinder. And upon ignition, they're going to create an imbalance onto the connecting rod. No matter if you have a balanced crank or not, it's going to throw off the balance just because of the amount of pressure or power that's being driven through the pistons onto the crank. Each cylinder is going to act in a different motion. It's going to produce different power. So going back to realizing that theory, why would you want your exhaust to flow less in the center 2 ports? Which ports flow with the least amount of restriction from the intake side of things? The inside runners, the ones closer together inside of the banks of the engine, the center 4 cylinders, especially with Fords, they will be designed with a shorter runner for less restriction. So just because of the intake designs, realizing that these shorter runners of these center 4 cylinders are going to flow more air, and they're going to be more positioned towards operating at higher RPM, the exhaust is actually balanced in the opposite direction. So more flow from the intake, less flow from the exhaust, creating a balanced amount of power being produced or spread onto the crankshaft. It's not only about CFM of each individual runner maximizing out, it's to balance the power coming from each individual cylinder. The original design of the LA or AMC cylinder head, there's obviously other cylinder heads that have that same orientation with the center ports together. Pontiac and Oldsmobile also had different configurations between their inboard ports to the exterior ports. It was all designed around the balance between the intake, the power production, and the exhaust and exhaust flow within the cast iron manifolds they were originally designed for. So any modification, swapping headers onto any of the engines out there, is going to produce a different flow characteristics and power from just the exhaust side. So again, I'm trying to think of a way that a cylinder head porter could verify this information. Again, this is theory that the original engineers behind these motors took into consideration when they were drawing them out on paper. They understood the flow characteristics and the power between all of the cylinders. Here's another example. Let's go to the Chrysler Slant 6. Okay, leaning tower power. Your center ports will flow more air because there's less resistance and the ports themselves are shorter. Your outboard cylinders have the most restriction, the most distance from the time the air is being fed into the engine until they're going into the cylinders. On a Slant 6, are all the exhaust ports exactly the same size? And do they flow similar? Are they shaped the exact same? Yes. Okay, so hopefully you're following along. This is an exact opposite design of what Chrysler learned after using the Slant 6 in most of their compact vehicles. The intake was imbalanced. The exhaust ports were balanced. But once again, where was the exit point for the Slant 6? It's centralized. So now your intake ports flow more because of less restriction and length that they have to travel to feed the cylinder. And the exhaust ports also have to travel, the flow needs to travel less distance to actually get to the exit point. So you're causing the center cylinders, the 4 cylinders of a slant 6, to generate more power than the outboard cylinders. And what do we all know about the slant 6? It suffers with high RPM performance, not only because of the control of the crankshaft within the main caps and girdles, it's also the flow characteristics restricting it from going at a higher RPM. You're having an imbalance of power being produced from each cylinder as RPM increases, causing an imbalance on the crankshaft. Even if you have mechanically balanced the crankshaft, the actual running engine creates the imbalance. So again, the differentiation in flow is designed from the original design. If you're trying to reach maximum power with a cylinder head with interior ports that are shaped different than the exterior ports, you're actually going to notice the greatest gain in power by utilizing the factory design of the center exit cast manifold. Yes, you heard that right. You will actually see a greater performance gain utilizing the factory cast iron manifolds than if you switch to a tubular header. Yes, believe it or not, than utilizing a tubular header that is not correctly fitted to your combination. Now, a tubular header, the primaries are also different length. They attempt to make them equal length with different bending and routing within the header. And they use a merge collector area to balance out the exact exhaust impulses. But the power production of an engine is affected much closer to the cylinder head and the exhaust valve. That will also dictate the flow of the intake charge that's going into that cylinder. There's a balance within the designs created for the balance of the rotating mass. So if you are modifying a Chrysler small block cylinder head, an AMC cylinder head, a Pontiac, and even some of the Chevrolet cylinder heads, even though their ports are similar in shape and configuration, make sure that you retain the balance of flow between them. So for instance, if you can flow 100 CFM out of your center exhaust ports in as cast configuration, and you can flow 120 CFM from your exterior ports, and you're porting the cylinder head for maximum flow, so on and so forth. Remember that balance, because if you increase flow of the center ports by 20 CFM, you should also be increasing your exterior ports by 20 CFM to maintain the original factory design to create the best balance in your rotating mass. If you're porting all of your cylinder ports to flow exactly the same, then you'll have the opportunity to obviously put on the tubular headers. But now you're only addressing one side of the balance issue, the exhaust flow. You're not balancing the intake flow. So say again, going to the Ford, the Windsor style Ford, sorry. Say the center 4 cylinders or ports flow 180 CFM and the exteriors only flow 165. That is also going to create an imbalance of how much power each cylinder has connected to each individual port. If you are porting a set of cylinder heads once again, if you're not creating a balance between all 8 cylinders, including the intake, because once again, once you go to dual plane or single plane intakes with different length runners, you're introducing an imbalance already to the amount of power that can be made by each cylinder. If you can then balance out the exhaust flow, you're introducing an imbalance within the airflow throughout the entire engine. Different cylinders are going to make different power. Modern day engines and engineers learned that throughout the decades. Modern day engines are designed with each individual cylinder being created exactly the same. The intake port approach is similar. The exhaust port is very similar as far as flow characteristics, and even the intakes are designed more to flow equally between the ports. An example I can share with you, when the transition first went to like fuel injection, direct port fuel injection, let's use the mid-80s Chevrolet design. The port runners themselves had a very sharp turn to them. Okay, again, that's kind of in opposition of creating power, but they were drawing from the exact same plenum. Okay, now the plenum was fed with obviously a throttle body that was way at the front of the plenum. So even within that design, your front two cylinders, because they're so close in proximity to the actual throttle body, the air can't necessarily make the turn to make it in and favor the front two cylinders. The number 2 and 4 cylinders will actually get more airflow than the front two. The plenum is designed to create a better balance within the engine. And what we are even seeing today with very large plenum, short runner manifolds, even in power adder conditions, even with the throttle body being at the front of the engine, it's depending more of the balance of the intake system because of the pressure of the turbos. Once you remove those turbos, the imbalance of power between all of the cylinders from the front of the engine to the back, once again, is going to create an imbalance. There's a reason why one of the best intake systems out there is a dual quad high rise. Almost in every single engine application, a spread large plenum area intake system will produce the most amount of power. But then at that point, if you're trying to equalize the intake side, you also have to balance out the exhaust. So again, remember that spread, the flow characteristics between the center ports to the outside, you need to maintain them in accordance to the intake you use. Again, reverse engineering your vehicle. The exhaust should actually be engineered into the combination before you choose an intake, because that will dictate what type of intake you're going to need to create the best balance with the running engine. If you know the cylinder head flow characteristics, most of your aftermarket tubular headers are going to flow similar between all the different tubes. The cylinder head is going to flow different. You have to do the exact opposite when it comes to the intake to create the best balance at extremely high RPM. So hopefully that kind of helps you out. Again, some of you cylinder head porters out there, Charles, while we've been seeing different tests going on with aftermarket cylinder heads, ones that are just being introduced into the market, yes, their flow characteristics of the different ports and the configurations are getting similar. When you bolt on a intake that does not flow as similar, you're going to see an imbalance within the higher RPM range. So again, allow the exhaust to dictate what kind of intake you're going to use. Obviously within the same RPM band of every other component of the engine, whether it be compression or the camshaft, power, range, so on and so forth. All the components have to be designed together as one entire package. But the exhaust has a lot to do with how the engine runs within a balanced configuration. I'm going to close the video with this. That rumpity rump that everybody loves to hear out of their exhaust system. Which exhaust note are you hearing? Are you hearing a combination of all 8 cylinders going off at the same time? Or are you hearing certain cylinders mixed in with it? Where does that sound difference come from? So with that, if you want your engine to sound meaner, you don't need to go and get a thumper cam or a rattler, so on and so forth. You can simply make your car sound deeper and have that rumpity rump by utilizing the factory equipment. It's that simple. So even you die-hard, factory cast iron only manifolds, your cars are sounding sweet. Okay, the original sound is actually better than the tone that a tubular exhaust system puts off. Even with modern day cars, they sound like an F1 car, that high pitch whine, so on and so forth. They have to modify the mufflers to be able to change that high pitch tune to a lower gargle. A straight piped muscle car will have that rumble that everybody loves. And it's because of the balance of airflow between the intake, exhaust, and within the manifold designs. The guys back in the 1960s in the muscle car era, the engineers, they knew what they were doing. Give them credit. Have a good idea. Have a good one.